Okay, welcome everyone. You're tuned into today's PIR live event with Dr. Sandy Raha from McMaster University. My name is Scott, and today Dr. Raha will discuss diabetes and what that means for adults and for kids. His research focuses on what mothers are exposed to during pregnancy and how that can affect your chances of developing diabetes. Before we get started, I'd like to welcome today's viewers watching the live stream. It's great to have you with us today. For those watching on the live stream, remember that you can tweet your questions to us during the half an hour using the hashtag AskPIR. If there's room in your tweet, please include your name and city and we'll give a shout out to you. So I look forward to getting to those questions, but first I'll turn it over to Dr. Raha. Dr. Raha, thank you so much for joining us today. Perhaps you can begin by telling us a bit more about yourself and the research you do so that we can understand how the human heart is affected by factors like exercise.
Fantastic. Thank you very much, Scott, and welcome everyone. And also thank you for joining us today. So as Scott said, my research focuses around how diet, how drugs that women are exposed to during pregnancy affects the health of their babies, and really focusing on how they might develop conditions like diabetes. So I am what we call at McMaster University a basic biomedical researcher. I focus on trying to understand how cells talk to one another. I focus on using animals as models to study human disease. We've been doing this for about 7 years here at McMaster. I wanted to share today some of my experiences and my expertise in the diabetes area with you. And I really look forward to engaging everybody in answering questions. So I hope you guys will have lots of questions, and I'll prompt you during my talk. So I have about 15 slides or so related to diabetes. I'm going to give a little bit of an overview about diabetes so to make sure everybody understands. And then I have a few slides at the end about my research specifically. And we can also have a discussion about details about my area of research, which is really called fetal programming. And I don't know if many of you have heard about that, but we can certainly talk more about that, and we don't need slides to do that. So let me start. So I have to share my slides. So can everybody see the slides now, I hope? Are you good there, Scott? Shall I begin?
Yes, looks like we're okay. Go ahead.
Excellent. So, oops, I think I have to go here. Here we go. So, first of all, how common is diabetes? There's actually a lot of people in the world with diabetes. We know there's almost 370 million people total that currently have diabetes. There's a lot more people that are sort of on the edge of having diabetes that we call pre-diabetes. In the USA, the most recent statistics say there's almost 30 million people that have diabetes. In Canada, unfortunately, our statistics aren't as up to date as they are in the US, but the 2009 numbers say there's about 2.3 million, and we know that certainly there's more now. So one of the questions I always ask my students is, when we look around the world, we see that different ethnic groups have different rates of getting diabetes. So if you look at the little map on the bottom corner of my slide, you can see that South Asians, as we call them, so people from Indonesia, India, Pakistan, this group of people seem to have a greater amount of diabetes, greater levels of diabetes in their population. So one of the questions I ask everybody, and something for all our viewers to think about, and maybe we can discuss this later, is why are scientists really interested in understanding the different rates of diabetes across the world? I'll let the people think about it, and maybe if people know, maybe they can tweet in an answer. If not, we'll talk about it later. So the first thing you have to understand is what is diabetes. And very simply stated, diabetes is when you have very high levels of sugar in your blood. People that have that know what a glucose meter looks like may understand that the normal number in Canada, when we look at the level of glucose in your blood, we say most people should have around 5. That's a concentration unit that we won't worry about, but the number on the glucose meter usually says 5. When you get numbers above 7, 8, 9, that's what we call pre-diabetes, and people that have diabetes quite often have numbers above 10. So that's how we measure glucose in the blood. But how does that come to be? Well, the slide that I have up here shows that glucose is really absorbed into your blood when you eat food. That sugar, so glucose really comes from sugar that you eat. The white sugar that you eat is a combination of two molecules. One is glucose and one is fructose. These are two sort of elementary sugar units that comprise standard table sugar. And when your body sees sugar, especially the pancreas, it sees the sugar and it says, oh dear, we have to take that sugar and we have to use it. So it sends another signal. This is a molecule called insulin. Insulin then goes to different organs in your body, like the liver, like muscles. And these organs see the insulin and understand that there must be a lot of sugar around that they need to take into their cells and store that sugar in the case of liver, or use that sugar in the case of muscle. And when that signal breaks down, that's when you get diabetes. That means there's lots of sugar in your body. We know that if you have too much sugar in your body, a lot of organs are affected. Organs starting from the brain to your blood vessels, to your kidneys, to certainly your liver, your heart. These organs all get affected. One of the parts of the organs that get affected by too much sugar is what some of you, especially those of you in grade 12, may understand. This is a part of your cell called the mitochondria. The mitochondria are responsible for making energy for your cells. And so that's an area that I study a lot, is how the sugar affects the mitochondria. We know that when you have diabetes, you get lots of symptoms. Anything from headaches to impaired vision, sweating, dizziness. Your heart gets affected. You can get very irritable. You get weakness. And a lot of these things come about because the sugar in your blood really affects the way your body receives oxygen and your body receives nutrients. So another question that everyone can maybe think about is exactly what happens to your blood vessels from the sugar. So this slide shows a little bit more in detail what I was talking about in terms of the relationship between the sugar in your blood and what happens with the liver. So the pancreas secretes two molecules. One is insulin that we talked about. Another one is called glucagon. So when there's high sugar in your blood, it comes to the pancreas. The pancreas senses the sugar and then releases these two molecules. If you have low sugar, you get glucagon release, and the liver that normally stores sugar can now release sugar so that you have enough energy. So when you get hungry, or if you haven't eaten for a long time, you will get an increase in the level of glucagon in your blood so that you can carry on normal activities. When you have too much sugar in your blood, like after eating, the pancreas will secrete insulin, and you will start storing the excess sugar. And the insulin also goes to other cells, like I talked about, and helps them to take in the sugar and store the sugar. And so the three of the most affected organs, other than the liver, are the ones that we have listed down there: the muscle, the brain, and the fat. People don't always understand the brain actually uses a huge amount of energy. The brain uses almost a quarter of the total energy in a day that you would use to carry on regular activities. So let's talk briefly about the types of diabetes and what this means. So most people think that there are two types of diabetes, type 1 and type 2. But there's actually a few other types that I'm going to talk to you about, and that may be something new that you learned today, and we can have questions about those. So people may be aware of type 1, and this usually occurs very early in childhood when there's damage to your pancreas. That means your pancreas can't make enough insulin. So when you eat, your pancreas can't respond and talk to the other organs in your body and say, take up the sugar. So these patients quite often have to wear insulin pumps or take insulin injections after meals to make sure that the other parts of their body can take in the sugar. And you get a lot of symptoms associated with type 1 diabetes. But the good thing is that now the kinds of medicine we have, most people with type 1 diabetes can manage it. And the one thing I'll keep telling people over and over throughout my messages with you is I'm a big believer in that a healthy, active lifestyle can really help to manage the diabetes. So proper eating and healthy activity and a healthy amount of activity are always helpful in managing this condition. And this is something that everyone should practice. Doesn't matter if you're susceptible to diabetes or not. The type 2 diabetes is something that we associate a lot with when people become obese, so poor dietary habits, or it can also happen when people get older. With aging, you might get damage to your muscles or your pancreas that result in type 2 diabetes. Type 2 diabetes really affects liver and muscle a lot, because what this condition really means is that your pancreas is trying desperately to tell these organs to take up the sugar and to use the sugar, but these organs aren't responding. So another question for people to think about, and we can come back to it in the discussion period, is why would these organs not respond? Somebody might know the answer, so I'm really hoping that one of you guys can sort of tweet in what the answer might be. But we can definitely come back to that. Generally, this condition is associated with high blood pressure. Sometimes lifestyle habits like smoking also affect the pancreas, and that results in the development of type 2 diabetes. If you have a bad diet, so diets very high in fat, quite often result in the development of type 2 diabetes. So my message to everyone, like I said, it's in the center of my talk, is maintain an active lifestyle, make good food choices. Usually diet high in fiber and low in fat is good. I'm not a physician, I'm a researcher, so I always tell people, make sure you get proper advice from your family doctors. So we're going to move on to what I think some of the types of diabetes that our audience might not know about. So I don't know how many people have heard about type 3 diabetes. Type 3 diabetes has become really evident in the last few years. It's been around forever, obviously, but we've called it type 3 diabetes probably over the last 10 years or so, because this is a condition that's linked with the development of Alzheimer's disease. We know that the brain is really affected by excess sugar. Sugar gets across the blood-brain barrier and can affect the cells of your brain. And what we've been finding is that some of the conditions related to Alzheimer's disease really are associated very nicely, or very tightly, as we say in the research community, with the development of diabetes, especially type 2 diabetes. And this, we think, is because the sugar gets into your brain and may result in damage to the cells of your brain, which results in Alzheimer's disease. So the development of Alzheimer's disease, some people, not everybody, but some people call this type 3 diabetes. And this is the area of research where I really focus on. I'm interested in understanding gestational diabetes. Gestational diabetes happens in women during pregnancy. So some women get very high levels of sugar. They're not able to manage the levels of sugar in their blood. They develop diabetes. Now, the problem is when the sugar in the blood gets to high levels, that can actually get across the placenta to the baby. The placenta is the organ that sits between the mother and the baby, and is really important for getting food to the baby and taking waste away from the baby. But it does a lot more than that. It sends out signals in response to the kinds of food the mother is eating. These signals help the health of the baby. But what we now know over the last 20 to 30 years is those signals can actually program the baby for its future health. So this is an area of research that we call fetal programming, or the developmental origins of health and disease. These signals are really important in predicting the future health of the baby. So one of the things that happens when the level of sugar in the blood gets really high is the babies may grow large. Then it's hard for them to be born because they're so big. But what we find is those babies 20, 30 years down the line have a much higher rate of developing diabetes. And this is some of the things that I was talking about. We know the diet. We know that actually if the mother has a lot of body fat, so if she's obese during pregnancy, the fat actually talks to the placenta. And some of my research focuses on this particular path of communication between the fat and the placenta and the signals that the placenta sends out to the baby. And we find that, and I'll show you some pictures in a minute, where the signals from the placenta really affects the size, affects the probability of the baby developing diabetes. So I'm going to show you an example of some of the experiments we did in my laboratory. So we took really overweight animals. So we can't do this in people, so we do it in rats. So we take really overweight rats, and we look at what happens to the baby. And when the rats are really big, so we're talking about some of our rats in this study were almost 1.5 kilos. That's the size of a small chihuahua. And what we found is those animals, the pups born to those big obese rats, were actually quite small. Rather than being big, the growth of the animals went in the opposite way. And we're very interested in studying why that happened. We also found a lot of the babies died in the womb. So a rat normally has between 17 to 20 pups. We found on average these obese animals delivered many fewer pups. So I have a picture here to show you just how small the animals were. That bigger animal you see on the bottom of your screen is a 3-week-old rat born to a normal pup, a normal mother, and the small animal is really a pup born to a mom that was very obese. So you can see the small animal is almost 1/3 the size of the rat born to the normal weight mother. This slide is really showing you where our research focuses. We want to really study the placenta and look at how the signals from the mother, from the fat, affect the development and growth of the placenta. So one of the things that we find is that, I'm sorry, somebody keeps calling me. I'm just trying to cut the phone off. Oh dear, hang on everybody, I'm just gonna unplug the phone. There we go. One of the things that we find is that certain areas of the placenta that I've got in the boxes, so one part of the placenta that attaches to the mother, and this part, so what you see in this slide is you've got the placenta that everybody sees, and then you can see sort of the part of the fetus, and I don't know if it'll come out, I'm trying to point to it. This part, that's the fetus. This is the part of the placenta that belongs to the baby. This is the part of the placenta that belongs to the mother. And we see there are big changes in the way these areas of the placenta function. What happens is that the baby actually gets less oxygen. Because the baby gets less oxygen, it doesn't grow, it doesn't develop properly, and that really leads to a lot of problems after the baby is born. So that's my talk. We can talk about some of the things that we've discovered, and I'm wanted to leave lots of time for questions. But if you want to learn more about my research, I've got my research lab website. And then we also have a McMaster Children's University that has a lot of programs related to the kinds of things I've talked about. And the link is also listed on the bottom. So you can come into those links and do some investigating. But now I'm going to turn it back over to Scott to let's take some questions.
Okay, very good.
Should I shut the slide presentation down?
Sure. Let me just make sure that I can get back to us again here. Yeah, so if you can take the slides down, then we should be okay.
So that's good.
All right. Well, thank you very much. That was definitely very interesting. Certainly another reason to stay healthy and to make sure we get our exercise in. In the time left, we have a few questions that have come in over Twitter. One from Victoria Black at PF in Aurelia. And she asks, if Alzheimer's is associated with diabetes, shouldn't Alzheimer's be manageable like diabetes?
So that's a really good question. There are other causes for Alzheimer's too. We know there are genetic causes for Alzheimer's. We think, or the literature thinks, that the probability of developing Alzheimer's increases if you have diabetes. So if you stay healthy, if you can manage your weight, you will certainly have a lesser chance of getting Alzheimer's, but it doesn't mean that it will go away totally.
Okay, very good. And one more from Luke Benner, who's at Patrick Fogarty Secondary School in Aurelia. He asked simply, is diabetes life-threatening?
That's a really good question. Diabetes can definitely be life-threatening because if you do not manage the level of sugar in your blood, as I talked about in that one slide where we had lots of areas of the body that were damaged, so you can have your vision damaged, you can certainly have your heart damaged. One of the things we know is if you have too much sugar in your blood, you tend to make more fat. That greater level of fat can then deposit in your blood vessels. once your blood vessels start to get clogged up, the function of your heart starts to get affected. When your heart starts to get affected, obviously there's life-threatening conditions that can happen. We also know that you can have, if the blood vessels in your legs get affected, you can actually lose the use of your legs because the blood doesn't circulate properly within your legs. So there's lots of reasons to try to manage diabetes very early on. If you have, if you're in what we call that pre-diabetes situation, which can be, so if you're going for regular physical exams, your doctor should be able to catch that possibility, and then they will tell you, maybe you can change your diet, maybe you can exercise more. We know both of these things really help to manage the diabetes. So it's a good way to manage that possible life-threatening situation that might arise as a result of having diabetes.
You talked earlier about how you actually perform your research and that you tend to use rats. Is there some reason for that? Is there some reason why rats are the best model as to how things might affect humans?
Yeah, that's a really good question. You'll find that, so when we use animals in research, we have to be very careful. We have to do it very ethically. In fact, I joke with my kids, I probably spend more money on my rats than I do on my kids to make sure that they're properly treated. And the reason why we use rats is because we study pregnancy. What we find is that the early parts of pregnancy, which are responsible for developing sort of blood vessels within the placenta, which are responsible for sending out those signals that help the baby to start developing. That very early part of pregnancy in humans and rats are very similar. When it gets to later on, the rats are not such a good model of what happens to humans, at least the pregnancy part. Because, as you know, when rat pups are born, they're not fully developed. They develop actually for about a week or 2 weeks after they're born, which is not the case for humans. Human babies are born fully developed, and we don't have to worry about what happens after they're born in terms of development. But the other big part of using rats and mice as animals to study diseases is, so a rat pregnancy is only about just over 3 weeks. So you can imagine if I had, first of all, it would be ethically wrong to study pregnancies in humans with the kinds of things we do. Some people study them in sheep because a sheep pregnancy is about the same time as a human pregnancy. And the problem is it's much more expensive. It's a much longer period of time. So, when you're trying to figure out what's going on, quite often you want to look at a lot of different conditions to make sure you're getting the right answer to your question. And so that means sometimes we have to use a number of animals. And with sheep being large and being so expensive, it's difficult to use lots of animals. And so those are the main reasons why we use rats, because of the short time, because we know a certain part of the rat biology is very similar to the human biology, and we're very careful to only interpret the data that comes from that part of its placental development.
I see. So in terms of following up with you don't usually use the rats to follow up on how they're doing later in their lives then, in terms of maybe you try to exercise them to reduce the effects of diabetes?
We do, but so what I'm talking to you about is in terms of what's going on with the pregnancy part of it. But once the rats are born and developed, the kinds of processes that happen in most mammals are fairly similar. So we do use rats and mice to do long. So if we want to look at what happens to the babies or the pups in this case, a long time after birth, we do use rats. We do exercise them, and we do know that exercising rats that are born to mothers that have weight problems or that have diabetes does in fact help. The interesting part of our study that we did was we had mothers that were obese. Once the babies were born, I showed you the difference in size. But what we found was even if we put those babies, the ones that were born to the heavy mothers, on a healthy diet, they still had an increased risk of developing things like high blood pressure. So that told us that there are things that happen in the womb that we don't understand, and that's where a lot of research is focusing now, to understand what happens in the womb and how we can actually reduce the risk of those babies after they're born in terms of developing lifelong diseases.
So we probably have time for a couple more questions here. You kind of left it open in your talk, but I was curious about the organs and how they don't respond to insulin. Why would that be the case?
So that's a great question, and that's something that there's a lot of research going on. But when I explain it to students, I put it like this. When there's high blood sugar in your blood, your pancreas sends out a signal, which is insulin, telling the other organs in the body to take up the sugar. After a while, if there's a constant level of high insulin, because your diet consists of a lot of sugar or a lot of fat, then what happens is the organs stop responding to that signal. So imagine if your mother or father were constantly yelling at you. After a while, you would just tune them out and stop listening to them. That's exactly what happens in your body. When there's this signal constantly to take up the sugar in your bloodstream, the organs in your body just stop responding. And we know there are certain signals. We know the proteins that are affected by this constant signal. These proteins are responsible for taking the sugar from the blood into the organs, and they don't respond anymore. They, what we call, essentially deactivate. And so that's why these organs stop being able to produce, stop being able to take in the sugar. But a lot of times these organs, so for example, the fat tissue fills up. If your diet is very high in fat, it fills up. It's like there's only so much you can store in the closet. Once you stuff the closet doors are going to break open and stuff's going to spill out. This is what happens with your fat cells. If you pass or exceed the limit that the amount of fat that can be stored in your fat cells, it spills out into your blood. It stops being stored properly. That fat goes to some of the other organs in your body and causes disease in those organs. For example, if fat gets stored in the liver, that's a big problem. It interferes with the functioning of the liver.
I see. That's a very apt analogy with the closet. I think that really explains things very well. Unfortunately, I think I'm being told that time is up for today. So I'd like to say thank you again to all of our viewers who tuned in and who sent in their questions over Twitter. And of course to you, Dr. Raha, for taking the time to answer our questions and share your very interesting research. I'm sure it was something that we were all very excited to learn about today. So, all right, everyone, we'll see you next week. And thank you again, Dr. Raha.
Thank you. Bye, everyone. Thanks for listening.